Hey folks, this lesson is scatterplots, graphs, tables, and equations. Okay, and then let's get started here. This is a scatterplot, you guys. Scatterplots are just ordered pairs. So this figure is going to be for examples 8 through 11. And it represents a grocery store that sells pints of raspberries and sells the price per pint for each week and sets the price per pint for each week. So down here is the prices, so that's my x-axis right here. So as the price increases, it looks like these dots are going down. So over here is the number of pints sold. So that makes sense. As the more expensive they get, they sell less. Okay, so the cheaper they get, they sell more. So they got to find a happy medium. So the scatter plot shows the price of the number of pints of raspberries sold for 19 weeks. So here's 19 ordered pairs right here. Okay, so along with the best fitted line, so they'll have this best fitted line equation given to you guys. So that's a graphing calculator exercise right there that you don't have to know how to do. They'll give you this equation right here. But these are just ordered pairs. So here's an XY ordered pair, here's an XY ordered pair. So all these XY ordered pairs, and this is called the best fitted line, the line that fits this data the best. It's like the average of all those points right there. Okay, so Y equals 233 minus 32x. Okay, so let's answer some questions. I just shrunk all that stuff up. So here's the first one. So according to the best fitted line, how many pints of raspberries would the grocery store expect to sell in a week when the price of raspberries is $4.50 per pint? Okay, so the price of raspberries is down here. It's my x-axis. So this is a x answer. So I'm going to plug in $4.50 into this equation. Y equals 233 minus 32x. Okay, so we'd expect to sell 89 pints given that equation right there. Okay, so for how many of the 19 weeks shown was the number of pints of raspberries sold greater than the amount predicted on the best fitted line? Okay, so that's how many points are above this line right here. So this is the best fitted line. This is the equation that gives us an estimate of all the other points that we guess on there. So we just got to count up the dots that are above because it said greater than. So all the dots that are above, 1, 2, 3, 4, 5, 6, and then these two, 7, 8. So there's 8 dots above the line. So the answer is 8 weeks. All right. What is the best interpretation of the meaning of the slope in the best fitted line? All right. Do you guys remember y equals mx plus b? Okay. So if we rewrote it as in mx plus b form, it's y equals negative 32x plus 233 right there. Here's our slope. 32 over 1. Well, 32 over 1 is, remember, slope is the change in y over the change in x. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is our change in y, and our y is the number of pints sold, and this is our change in x. So as the price increases for each dollar, we'd expect to sell 32 pints less. So for each dollar increase, then we'd expect to sell $32 or 32 pints less. So as this increases by $1, this decreases by 32 pints. Okay, so what's the best interpretation of the y-intercept of the best fitted line? Okay, so the y-intercept, this is 233. I had it changed on the other ones and forgot to change it there. So the y-intercept, you guys, is when x equals 0, or where this line crosses the y-axis. It would be way up here somewhere. So the y-intercept is when x equals 0. So that means when the price is 0. So it says at a price of $0, they would be selling 233 pints of raspberries. Well, that's not realistic, you guys. If they're giving away the raspberries, they'd probably be needing more than 233 pints. They'd need a whole bunch more. So at a price of 0. So over here it starts to get unrealistic over here. So even at a price of 50 cents, you know, I don't know, it'd be way up there. So it just gets unrealistic when the price is 0 right there. Okay. All right. So here the table to the right gives the initial number at time t equals 0 of bacteria placed in a growth medium over a number of bacteria growth medium over 3 hours. So here's time t equals 0, 1, 2, and 3 hours right here. Which of the following function models the numbers of bacteria? N of t, the number of bacteria over the time after t hours. Okay, well, they're trying to trick you right here. Let's make these 10 to the third. So 1.6 times 10 to the fourth. If I make this go to the right one place, it would be 16, and that would decrease that exponent times times 10 to the third right there. Similarly, if we make this decimal go one place to the right, it would decrease that right there. So 16 times 10 to the third is the same as 1.6 times 10 to the fourth. And the reason why they did that, you guys, is they wrote these to hopefully trick you to that you don't see that it's just being a multiple of 4. Look, 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. So when it's a multiple of 4, that is 4 to the power right there. Okay, and this 10 to the third is our 1,000. 10 to the third is that 1,000 right there. So we get 1,000 times 4 to the t power right there. Okay, so 4 to the 0 is 1, 4 to the first is 4, 4 squared, 4 cubed, and so it's so here's our 4 to the power right there, 4 to these powers right there, times 10 to the third. Well, 10 to the third is that 1,000, so it's choice D right there. Okay, simple interest formula. Okay, sorry they don't give these to you. They're not hard, you guys. They just don't give them to you on the SAT, but you're supposed to know them. So simple interest is your amount that you put in right there. I'm sorry, this is your amount you put in, the original deposit. So your principal. So your principal times the quantity 1 plus RT. R is the annual interest rate. So say it's like 5%, it would be 0.05, and T is the time in years. So simple interest rate. Otherwise you have compounded interest, and compounded interest is the principal times the 1 plus R over N, and N is the number of times it's compounded per year. So if it's compounded quarterly, quarterly means 4 times a year, so N would be 4. If it's compounded monthly, it would be 12. Okay, how many times per year it's compounded? Okay, R is your interest rate, and still N is how many times it's being compounded, and it'll tell you whether it's simple or compounded. Okay, so you got to know which ones you use. So this bank offers $1,000 certificates of deposit at simple interest rate. So we're going to use the simple interest rate, 4%. So this is 0.04. Okay, so the bank is selling the certificates with terms of 1, 2, 3, or 4. These are misleading. We don't need those numbers right there. Which the following function gives the total amount. Your total amount is your A in dollars a customer will receive with the term of K years. Okay, so this is T. T equals K. So here's our simple interest formula. So it's the principal times 1 plus RT, where R is our rate and our T is our K. Okay, so it's going to be this formula right here. So this is going to be 0.04, and then it's going to be times K. So we're going to put it times K. So it's going to be choice B. Okay. All right. Let's do a compounded one. So this same bank is offering the $1,000 certificates of an interest of 4% a year, compounded semi-annually. Semi-annually means twice a year. Okay. So the bank is selling certificates with 1, 2, 3, or 4 terms. Again, we don't need those. So which of the following functions gives the total amount of A in dollars the customer will receive when a certificate with a term of K, where T is equal to K years, is finally paid off? Okay, so we're going to use this formula right here. So the principal, 1,000, 1 plus the 0.04 divided by 2, okay, and then to the 2 times 0.04 power right there. Okay, so we're going to use that. Going to plug that in right there, and then 2 to the T power, which is 2 to the K power, because K equals T right there. All right, and then 0.04 divided by 2 is 0.02, so it's going to be 1 plus 0.02, and so when we add those together, we get choice D right there. Okay, 1 plus 0.02 is 1.02. Okay, all right. So each day, Julie walks, jogs, and runs for a total of 60 minutes. Okay, so here's her, over here is her speed. So as we go higher up, she's going faster right here. Okay, down here is her time for 60 minutes. So she's going a speed of 4 right here for, it looks like, about 5 minutes, and then up here from looks like about 7 to about 20 minutes right there. She's going 6 miles per hour, and so it's asking which of the segments graphs represents Julie's speed is the greatest. Well, the greatest speed is up here at the highest way up there, so there it is up there. So what is the time interval? So it looks like about, I don't know, 20 or maybe 19 to about, I don't know, 35 or 34 at the speed of 8. So this one right here, choice B right there. Okay, all right. So probability, a real quick example of probability. Probability is a fraction answer, and you get your fraction by doing the number of favorable outcomes divided by the total number of outcomes. For example, this is a real easy example to show you how we get probability answers. So a bag contains 3 red marbles, 4 blue, 2 black, 1 green, and 1 yellow. So we got to find the bottom number for the total. 3 plus 4 is 7, 8, 9, 10, 11, 12. So the bottom number is 12. What's the probability at random if we pull a red one out? It would be 3 twelfths. 3 twelfths reduces to 1/4. Okay, what's the probability we pull a blue one out? That would be the 4 blues, so 4 twelfths, which is 1/3. Okay, it's blue or black. Well, there's 4 blue, there's 2 black, so we're going to add 4 plus 2 is 6, 6 twelfths, which is 1/2. How many of them in there are purple? 0, so 0 twelfths is just 0. How many in there are not purple? All of them, so 12 twelfths, which is 1. Okay, all right, so here's where we might see this. This is called conditional probability. So this table came from a 2000 statistical abstract of the United States and shows the age and marital status of women in thousands of women. Okay, so if a woman is chosen at random, find each probability. She's a young married woman. Okay, so I got to go fast. I'm limited at 15 minutes on these, so I got about 7 minutes left. So anyways, here's young, married, so this is going to be my top number, 7842, and the total is going to be this number. That's my bottom number right there. Okay, so we get that. Now they might change it to a decimal, so you do top divided by bottom with your calculator. Okay, if this is a calculator one. If it's not, then you just take that as your answer. She's a widowed woman. Okay, so a widowed woman would be in this one here, given that she's at least 65. So that would be this one right here. So the 8385, again, divided by, it says she's a widowed woman. Okay, so we got to do the total of the widowed women. Okay, so the total changes on this. So here's the favorable. Here's this one. She's a widowed woman, given that she's at least 65. So we're only in the 65 or older column. That's why we use this total right here. Okay, all right, let's try that with this one. She's a married woman, given that she is young. Okay, so here's the total for the young, so we're going to use this as our bottom number, and this is going to be our top number. Okay, so there's our married woman, given that she is young. So it's a conditional probability. We're focusing on just the young ones here. Here we're focusing on just the ones that are 65 and older, so we use the different totals right there. Okay, this one just says she's a young married woman, so it's the total out of them all. Okay, remember these are in thousands, so you can think of it, add another 0, 0, 0. Well, this would be also 0, 0, 0, so the zeros would cancel anyways. Anyway, so this histogram shows the number of hours worked by 40 employees last week in a pet shop. The first bar represents all workers who worked at least 10 hours but less than 20. Okay, and this bar says she worked at least 20 hours but less than 30, and so on. So this would be 30 hours but less than 40, 40 hours but less than 50. So here there are, looks like 5 people in there. Here there's one person that worked 50 hours but less than 60, and then here that looks like there are 2 people that worked over 60 hours. Which of the following could be the mean and the median of the hours worked? Okay, now all histograms are all in this, so we include the left bar but not the right end bar. So that's all histograms on the SAT include the left side but not the right side. Okay, all right, let me shrink all that up right there. Okay, all right, let's find the median first, you guys. Okay, so with 40 employees, the median is the middle number, so that would be out of 40 people, it would be the 20th and 21st numbers. Okay, the 20th and 21st numbers. All right, so here's 6 right here. All right, so the first 6 employees worked at least 20 and at least 20 but less than 30. Okay, so and then so the next 17 right here are up in here. So here's 6 and then here's 17 more, so 6 plus 17 is 23. So our 20th and 21st is up here in this area. So the next 17, meaning the 7th through the 23rd person, will be at least 10 hours but less than, I'm sorry, at least 20 hours, but less than, at least 20 hours, but less than 30. So I made a mistake right there. This should be at least 20, but less than 30. Okay. All right. So this means that the 20th and 21st, the mean is going to, the median is going to lie somewhere in this, at least 20, but less than 30. Okay. So there's at least 20 less than 30, at least 20 less than 30. The median is at least 20 less than 30. Look, this one we can cross off D. We know it's not choice D. Okay. So that should be a 20 right there. I'll fix that because I got to teach this in class also. Okay. So So let's find the mean. Okay, so each of the 6 employees worked at least 10 but less than 20. So if we do 6 times the at least 10, they worked at least 60 hours right there. Okay, let's see, I'll fix that later. Okay, I'm out in my truck, you can hear an ambulance going by. So the total number of hours for the next 17 employees right here is at least 17 times 20. So 17 times 20 is 340. And we keep doing that. So this one's going to be, I'm just sliding that up right here. This one here is going to be, what's that, 9 times 30 right there. So we're going to do 9 times 30. So this one's going to be at least 270 hours. Okay, so this one here was at least 60 hours. This one was at least 340. This one's at least 270. This one's going to be at least, looks like 5 times 40, or at least 200. 1 times 50. So this is going to be the least amount of hours that they can work. Okay, so to find the average of these, we add up all of these numbers, and then we're going to divide it by the 40 employees right there. So the 40 employees worked at least 26 hours. Okay, at least 26 hours. The mean, that's not at least 26. That's not at least 26. We can wipe out choices A and B. So the correct answer is choice C. All right, that's a hard one. Okay, let's do one more here, you guys. Okay, so the dot plot shows the goals scored by 2 soccer teams, each with 24 games. Which of the following correctly compares the standard deviation? The standard deviation is how much spread out they are. How much spread out all of them are. Okay, so the standard deviation of the goals in Team A is smaller. The standard deviation of the goals in Team B is smaller. How about the standard deviations are the same? And you're thinking, well, how do they spread out, you guys? Okay, so with Team A, the large majority of the scores are 3 and 4. There should be a 4 right there. Okay, so 3 and 4. Okay, with only a few scores with 0, 1, and 2, and 5 right there. Okay, so the average is somewhere between 3 and 4, and if we added them all up and divided it by 24, we'd find out it's actually 3.25. Okay, so the average is 3.25, but we know it's somewhere in between there, right there. Okay, with Team B, the scores are more evenly spread out across all possible scores, with many not close to the average score, which is 2.5. Golly, typo city. That'll be all fixed anyways when I teach this in class. Okay, so because the scores with Team A are more closely clustered around Team A, or more in this area right here, the standard deviation of Team A is going to be smaller because they're less spread out like in these. They're so spread out in this guy right there. All right, you guys, I hope that makes sense, and take care. So it's choice A.